Hey everyone, this is Mr. H here. Going to go through 2.3 measures of central tendency. This is the classic mean, median, and mode section with some more advanced means as well. The idea is we're trying to find a value, one value, that represents the center or a typical entry of an entire data set. And the standard ones to use are the mean, median, and mode. The mean, or sometimes called the average, does have some formulas that you see here. And remember, this is the notes for chapter 2 that you can follow along if you print them out. But you have population mean and sample mean. Basically, the calculation is the same, but the symbols will be different. So here's your first look at the symbol mu. We're always going to use that when we talk about the population mean, and the X bar is the symbol we'll use when we talk about the sample mean. But if you look at the formula, the top part is sum of X's. That just means add up all of the data values. And then the bottom is divide by the N. Capital N is the sample or the population size. So how many values in the data set. It's the same for sample mean. Sum them up, divide by the N, the sample size, how many data values there are. Okay. Mean and mode, median and mode we'll get to in a minute, but let's just try an example here real quick. The following is a list of heart rates from a sample of 16 women. Find the mean, median, and mode. So let's just get the mean right now. So it's a sample. So if I'm using the correct symbols here, I'm going to use the X bar. And the formula is sum of x's divided by n, right? So sum of x's just means you're taking and adding up all of those values. I'm not going to write them all. I'm going to type them all into my calculator, right? I'm going to calculate all that and hit enter, and then I'm going to divide by 16 because there are 16 numbers. Okay, so let me try that in my calculator now. If you want to hit pause and try it yourself to see if you get the right answer, that's great. Okay, so for the top, I've got 1263. Dividing that by 16 comes out to be 78.9375. Okay, that would be the sample mean. Okay, the median is, if I go back up to what the median is, it's the value that lies in the middle when the data set is ordered. So it's important when you're finding the median to first order the data values, okay, from smallest to largest. If there is an even number of entries, you don't have a middle one. So that's when you would just average out the middle two data entries. Okay, so let's try to do this one. I'm going to first order them. Okay, so that will be the order. I just did it real quick. Takes a little time, a little tedious. Again, when we get to some StatCrunch technology, we'll have some faster ways to do that, but it's not too bad to do it by hand. Okay, so for the median, I'm just looking for the middle number. Now, because there's 16 numbers, I have an even number. So that means I can divide them up into 8 and 8, right? So let's see, if I count it out, 1, 2, 3, 4, 5, 6, 7, 8, right? So there would be the division of 8 in the lower and 8 in the upper. Okay, and so what I have to do to find the median is just average those two together. Right? So the average, or right, what is right in the middle of 79 and 80? I mean, you can almost eye that one, 79.5, or just add them up and divide by 2, right? So the median, I could just do 79 plus 80 divided by 2. 79.5 would be the median. Okay. Now, again, if you had 17 numbers, there would be an exact middle one because you'd have 8 to the left, 8 to the right, and then 1 right in the middle. That would be the median. Okay. So that's median, not too bad. key is ordering the numbers from smallest to largest. Okay, final thing is the mode. The mode is just which number occurs the most frequently, or with the greatest frequency. Do we have any that repeat? Okay, so we do have 75 repeating. There's two 75s, and then there's two 80s. Okay, and there's no number that has 3, right? So the highest is 2, and there's two numbers, 75 and 80. So this one has two modes. So the mode, we would call this bimodal, 75 and 80. Okay. So all of those are measures of center in a little bit of a different way. Okay. If we looked at the values, say in a graph, would those represent the center? They probably do. All of them seem, usually the mean and the median do a pretty good job of representing the center. Mode is hit or miss, right? You might have a lot of numbers that are just happen to be at the bottom end of a set. So when you get to questions like this, decide whether or not the values represent the center. So definitely the mean does, the median does, right? Mode, well, there's two of them. And I would say the 80 is a little better than the 75, right? But they're both not bad. Okay. Okay. The next thing we're going to look at is a little bit more about the mean. The mean is a reliable measure of the central tendency, right? And the reason for that, it takes into account all of the data values, right? The one disadvantage is that it can be greatly affected by outliers, right? Which is a value that's just far removed from the others, okay? So let's try this. Let's take the value 62 in your data set, and let's change it to 190, right? So we're gonna remove the 62, and we're gonna add in the 190, and then recalculate the mean, median, and mode, okay? Try that now and see what you get, and then we'll talk about it. Okay, so here's what I got. If we replace the 62 with the 190, the mean I got 86.9 approximately. And then the median just changed a little bit. The mode didn't change at all. So the point of this is when you have an outlier, the mean is most affected by it. Okay, the median and the mode aren't. Okay, so if you have a data set with some outliers, you probably want to use the median as your measure of central tendency as opposed to the mean. Sometimes what happens is outliers will just get removed from a data set, and then you just calculate the mean without the outliers. I mean, that's another idea. Okay. Another problem, number 3, we have the favorite color of 50 children shown below. Find the mean, median, and mode of the data set. Now, this is a little bit weird because notice here in this survey, if we ask children what their favorite color is, the responses are qualitative. In other words, they're just categories or words. They chose yellow or green or red or blue. Right? Here, so the data values are not numbers, right? I mean, we have numbers here because we have yellow 7. That just means 7 people said yellow. 7 is the frequency, but it's not the data value. The data values are yellow, red, green, or blue. So if you had to find the mean, what's the mean color? How are you going to add up colors and divide by the total number of children? You can't, right? So when the data values are qualitative, not numerical, there is no mean. Same for the median. Like, how are we going to arrange the colors in order, right? So there's no median either. And this is where the mode is actually useful. But there is a mode, because what it was the most common color chosen? It was red, right? There's 22 children that said red. So the mode is red. Okay, so again, when your data set is non-numerical, you cannot find a mean and you cannot find a median. You can only find the mode. Okay, next type of mean we're going to look at is a weighted mean. The weighted mean, it has a formula. Looks a little crazy, but we'll break it down. This is where you have weights associated with categories. A good example of that is calculating a grade. So here we have a breakdown of categories for tests, homework, quizzes, etc. And then we have your scores. Okay, so what I like to do is make a little table for these. And we have scores and we have weights. Okay, and let's see, for tests, what did you get? Your test mean was 82, and that's weighted 50%. For homework, your score was 86, and homework is weighted 15%. For quizzes, we didn't do so well in quizzes, got a 50. How much is that worth? 10%. The final, you got an 80 on it, and the final exam is worth 20%. And then finally, there's a project that's worth 5%, and we got a 70. So the question is, what is the final grade of this student? Okay. The weights don't necessarily have to add up to 100%. This one they do because it's the total grade, but we could just find the grade, in the middle of the semester or something when not everything has been done. But anyway, let's find this weighted mean. The idea for this formula, if we break it down, the top is X times W and sum them up. So multiply the pairs together and then add them all up. So I'm doing 82 times 50 plus 86 times 15 plus 50 times 10. We gotta keep going, plus 80 times 20 plus 70 times 5. Okay. So that got a little sloppy, but I'm multiplying all the pairs together. That's my numerator. And then I'm going to divide that by the sum of the weights. 50 plus 15 plus 10 plus 20 plus 5. Okay, so let's try that now and see what we get here. Okay, so at the top, I got 7,840, and then summing up the bottom was 100. And so then the overall grade here is a 78.4 for my overall average. Ooh, the student just fell short of a B and got a C, okay? So again, make a little table with scores and weights, multiply the pairs together, add them all up for your numerator, and then divide by the total. Try that out with your own calculator, make sure you get that, make sure the calculation works out right, and you're on your way. Okay, I'm gonna stop there for this one. I'll continue on the next one. Thanks. Talk to you later.